Hello, mathematicians. Here we are at Chapter 8, Lesson 2. We are going to be talking about function rules. So go ahead and get your book open to page 587. We are going to start on this first page because there's some key vocabulary words here that we need to discuss. So let's take a look at this. It says, a sequence is a list of numbers in a specific order. Each number in the list is called a term in a sequence. So, for example, if I have a set of numbers, 5, 10, 15, 20, 25, that is a sequence of numbers. Now, each of those numbers are called terms. Okay, they're each separate, just like when we were talking about our algebraic equations. We talked about terms, like terms. So a term is anything that is divided by an addition or subtraction problem. Okay, so we're going to talk about two quick things here. We're going to talk about arrhythmic sequences and geometric sequences. Now, it says arrhythmic sequences can be found by adding the same number to the previous term. So, the definition, adding the same number to the previous term. So, let's talk about that, for example. So let's say that I started off with 2, and let's say I was adding 3 to every number. So if I'm going to start with 2, and let's say I add 3, that's going to get me to 5. If I'm at 5, notice from here to here I added 3, and I'm going to add 3 here, so 5, 6, 7, 8, that gives me 8. I'm going to add 3, 8, 9, 10, 11, then my next number is 11. I'm going to add 3, 11, 12, 13, 14. Okay, you see the pattern. So I'm adding 3 to every number. Okay, so what's different about that in a geometric term? Each term is found by multiplying by the previous term. So here we are multiplying the same number. Okay, so we're multiplying the same number throughout the sequence. So for example, let's say I started with 3 and I was multiplying by 2. So to get to my next number, I'm going to times it by 2, which gives me 6. Now I'm at 6. I'm going to times it by 2, which gives me 12. Now I'm at 12. I'm going to times that number by 2, which gives me 24. Okay, you see the difference. One is adding, one is multiplying. All right, take a look at the next page. So here we go. We're going to take a look at this example. So we are basically trying to figure out what the rule is. Are we adding? Are we adding? Are we multiplying? How do we get from one term to the next? So for example, you see this. It says 7, 14, 21, 28. Here's the thing, 6th graders. If you know your multiplication facts, like you should, when you look at those numbers, you should know, okay, well, all of those are multiples, right? Because 7 times 1 is 7. 7 times 2 is 14, 7 times 3 is 21, 7 times 4 is 28. But take a look at when you look at them going from each term. How I get from 7 to 14, I add 7. How I get from 14 to 21, I add 7. How I get from 21 to 28, I add 7. Therefore, my rule is I'm going to add 7. Now, take a look. So our rule is add 7. And then we're supposed to write the next 3 terms. So if I'm at 28, then I'm going to add 7. So my next term would be 35. Now I'm at 35, I'm going to add 7, which would be 42. Now I'm at 42, I'm going to follow my rule. I'm going to add 7, which is 49. Okay? All right. Let's jump down here and let's practice these. So here's what we're going to do. We're going to start here. We're going to figure out the rule. Okay, we're going to figure out the relationship. And then what we're going to do is from there, we are then going to decide how we can figure out the next 3 terms. Okay, so I have 0 to 15, okay, which I know I just don't have a lot of room. And I need room and you need room. So rewrite these, okay, and then we're going to have our next 3. 1, 2, 3. And we'll just do it like that. All right, how do I get from 0 to 15? Well, I can add 15. Okay. All right, well, let's see if that rule sticks through. How do I get from 15 to 30? I add 15. Ah, it's working. How do I get from 30 to 45? Add 15, which means my rule is plus 15. Now, how do I get from 40, I'm at 45, and I add 15, which gets me to 60. Now I'm at 60. I'm going to do my rule. Add 15, 75. Here I am, my last one. Add 15 gets me to 90. So my rule is add 15 and my next three numbers are 60, 75, and 90. Okay? Now, again, not all of them are going to be adding. For example, take a look at number 2. Take a look at this relationship, 2, 4, 8, 16. Well, it kind of sounds like 2, 4, 6 would be counting by twos. So now we got to change our thinking. So how could I get from 2 to 14? Well, I could add 2, which is true. 2 plus 2 is 14, but or 2 plus 2 is 4. When I go to 4 and I add 2, do I get 6? No. So I know adding 2 does not work. So now let's try another way. How do I get from 2 to 4? I can multiply by 2. 4 times 2 is 8. 8 times 2 is 16. And then you're going to see that we're going to add, or not add, we're going to multiply by 2 to get my next three terms. Okay? So let's take a look at D. Okay? So let's take a look at D. So here we go. When we are at D, you're going to see that we are doing 3, 6, 12, 24, and then we need to figure out the next three numbers. So taking a look, how do I get from 3 to 6? Well, I could add 3. Okay, so if I add 3, I'm going to see if that rule works. 6 plus 3, 6 plus 3 is 9. It is not 12. So I know that adding 3 does not work. So now let's rethink our logics. We know it's getting bigger, so we know we're either adding or multiplying. So what if I multiply by 2? 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. 48 times 2 is 96. And then 96 times 2 is 192. So my rule here was times 2, and my next three numbers were 48, 96, and 192. Let's take a look at, let's take a look at this one. I like this one. All right, so take a look. I have 4.5, 4, 3.5, 3. Notice that my numbers are getting smaller, which means I'm obviously going to be subtracting. How do I get from 4.5 to, or subtracting or dividing? Okay, how do I get from 4.5 to 4? I'm subtracting 0.5. How do I get from here? I'm subtracting 0.5. From 4 to 3.5, 0.5. 3.5 to 3, 0.5. So I'm going to subtract 0.5, and I'm going to get 2.5. I'm going to subtract 0.5, which gives me 2. I'm going to subtract 0.5, which gives me 1.5. So my rule for B is subtract 0.5, and my numbers are 2.5, 2, and 1.5. I'm not sure if you can see that decimal in there, but it's there. Okay? All right, let's take a look at the next page, which is 589, right? That's the right way. Perfect. Okay, so now we're going to try to find the rule in the table, okay? You're going to see it says a sequence can also be shown in a table. The table gives both positions of each term in the list and the value of the term. So notice the list, 8, 16, 24, 32. And the position, meaning 8 is the first one, that's the first number, 16 is the second number, 24 is the third number, and 32 is the fourth number. So now what we want to do is try to find the relationship between them. Okay, between here and here, between here and here, between here and here, between here and here, and figure out the relationship between these numbers. Okay, so let's take a look at what happens down here. It says use the words and symbols to describe the value of each term as a function of its position. Then find the 10th term. Okay, so the 10th term, meaning this one, it wants to know the 10th term. Okay, so we're going to change that n with 10. Okay, so now when I look at this, I can see, okay, 3, 6, 9, 12. So what looks like we're going to be doing is our rule is going to be, let's see, well, from here to here, I'm multiplying by 2, right? Okay, which I could keep doing. However, I've got to get to the 10th term, which means I would have to go and find 5, 6, 7, 8, 9, which is fine, it's just more work. So now I want to find the relationship between these two, between the position and the value of the term. So how do I get from here to here? Well, how do I get from 1 to 3? Well, I could times it by 3 or I could add 2. So let's see what happens if I times it by 3. Okay, 1 times 3 is 3. All right. 2 times 3 is 6, so it works. 3 times 3 is 9. 4 times 3 is 12, so therefore 10 times 3 should give me 30. Okay, now notice that we were taking whatever our n number was and multiplying it by 3. So if I said, what is the 8th term? Okay, so what is the 8th term? Well, remember our positions on the front and our terms on the bottom. If our rule is times 3, I'm just going to take 8 times 3, which is 24, which means really that the 8th term is going to be 24. Okay, let's take a look down here. It says use the words and symbols to describe the value of each term in the function of its position. Then find the value of the 8th term. So they want these to be 8. Okay, the 8th term, which is fine. Notice you have 2, 3, 4, 5, and then it goes to 8. So we have to find the relationship between the position and the value. So 2 to 12, well, I could multiply by 6. Well, that would work. 2 times 6 is 12. 3 times 6 is 18. That one works. 6 times 4 is 24. That one works. 6 times 5 is 30. That works. So 8 times 6 is 48. So therefore, the answer would be 48. And then our rule was times 6. Or you could say multiply by 6. Or you could say 6 times n. Okay, or 6x, or whatever it might be. Okay, use your words, whatever works. Let's take a look at the next one. How do I find the relationship from here to here? Well, 3 to 7, well, I wonder if I know if I add 4, 3 plus 7 is 4, so I wonder if adding 4 works. 4 plus 4 is 8, that works. 4 plus 5 is 9, that works. 4 plus 6 is 10, that works. So therefore, my rule is adding 10, 8 plus 4 is 12. So we believe that the answer is 12, and we would say add 4, or we would take n plus 4. Obviously, the way that you should write it is with the variable. Okay, let's take a look at the next page, and let's do number 1. Okay, so take a look. It says, describe the relationship between the terms in the sequence, and then we're going to write the next 3. So I have 13, 26, 52, 104, and I've got to write the next 3 and find the rule. Okay, well, so 13 plus 13 is 26, but 26 plus 13 is not 52. So what if we times it by 2? 13 times 2 is 26. This is where a calculator is going to come in handy. And again, Mrs. Horner has already done the math, so you might want to also do it too. So 26 times 2 is 52. 52 times 2 is 104. 104 times 2 is not 280, 208. Okay, that's my next term, times 2. 208 times 2 is 416. 416 times 2 is 832. So my rule is we are taking and multiplying by 2. Okay, all right, the previous number by 2. All right, next one. Use words and symbols to describe the value of each term and the function of its position. Then find the value of the 15th. So this is the 15th term in the sequence. So how do I get from 1 to 2? How do I get from 2 to 4? Well, what happens if I multiply by 2? So 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. So 4 times 2 is 8. So therefore 15 times 2 is 30. So my answer is 30. And so we are taking whatever number, whatever term, and we're multiplying that by 2. So we can do it like this. We can write it as 2n. You can write it as 2 times n. Whatever term, you are multiplying it by n. So if I said in this example, what would be the 20th term? What would be the 20th term? That means I'm just going to take 20 times 2, and it would be 40. All right, we're going to go ahead and stop there. You've done a great job today. Hopefully it all makes sense. We're going to be going over some stuff in class. Good job.